the conversion that's required when we adjust our units depends on that exponent in the appropriate dimension. So if this is something feet per meter square, then we're going to have the square of the conversion constant. If it's feet per meter, we want to convert from meters to feet. It's going to depend on first power. If it's feet per meter and we're going to convert time, it doesn't depend at all because it's time to the 0th power. Okay, what's particularly interesting, folks, is that because we can describe the dimensions associated with quantities as products of powers, there are some quantities that have all powers, all exponents of 0 associated with them. So we saw here length per foot. That's cost to the 1 power, length to the -1, and we wrote it as t to 0. And maybe if we have persons in our model, we would have written p to 0 for person 0. Okay. But there are some quantities that are going to have consistently 0 for these. Cost to the 0, length to the 0, time to the 0, person to the 0. We call these as being of unit dimension. Or we call these dimensionless quantities. Now this is somewhat of a misnomer. They do have a dimension. It's just a very special dimension. It's a dimension where they depend, they just have the exponent 0 for each of the dimensions. But these quantities are very deep because if we change units, they don't change. If we change any of the units in the model, we don't change. So let's talk about some dimensionless quantities. Well, let me ask this. Can anyone here come up with a dimensionless quantity? You use them all the time. You use dimensionless quantities all the time. They're not going to depend on any units. They're independent of the units. Can anyone give me an example of a dimensionless quantity? Doesn't depend on the units you use. Doesn't depend on the yardstick. You could talk to someone from another planet. You could talk with someone in the US who's using imperial units, and you'll be speaking metric units. And you could talk with them, and still the value would be the same that you're talking about. Give me an example of a quantity like that.
Pi or E or something.
Okay. So that's an interesting question. Whether pi is dimensionless. I believe it, yes, it would be dimensionless, actually. And that's a dimensionless value. And what you're getting to is the reason you pick, the reason pi is so significant is because it's a ratio. It's a ratio of a circumference, right, to a diameter, to the radius. So here we have a quantity. It's a ratio. It's a ratio of two lengths. And it doesn't depend if you measure the radius, as long as you measure both in the same unit. You measure the radius in feet and the circumference in feet, that's fine. If you measure it in meters